Hey guys, welcome to my channel Code with Kai, and problem for today is Leetcode number 35, search insert position. Okay, let's say our elements are like this: 1, 3, 5, 7, 9 and 11, and a target that we want to insert is 10. Okay, so where at what position should we insert this to maintain the order? Okay, so what we can do is we can index it out first: 1, 2, 3, 4, and 5. Okay, these are all 5 indexes I have. Uh, okay, now what we will do is we will do a linear search, meaning I'll place the I pointer on the leftmost side and I'll go from left to right. Okay, and as I go from left to right, I'll check just one condition, that is whatever is at I, is it less than or equal to target? Okay, that is what I'm going to check. That means in the first iteration, what it will do is it will check, is I, that is 10, I that is 1 less than equal to target? Okay, yes, it is less than equal to target, so I'll just move on. I'll continue the loop and I'll shift I to the next index. Okay, then I'll check, is my I, that is 3, whatever is at 3, is it less than target? Okay, our target is 10. Yes, that is correct. So I'll again move I pointer to the next element, to the next index. Okay, so in iteration 3, what it will do is it will check, is my 5 less than equal to target? Yes, that is correct. So I'll again move I, and in the fourth iteration, I'll again check, is 7 less than equal to target? Yes, it is correct. Then I'll move again, is 9 less than equal to target? Yes, it is. So I'll move again. And once I reach index number 5, okay, now if you see the element that is in uh, right here is 11. So I'll check, is 11 less than equal to 10? The answer is no. And the moment we have the answer as no, okay, that means this is where our target should be. Okay, so that means if we place 10 right here, okay, if we placed 10 right here, it would perfectly fit. Okay, so that means the index that it is going to be we have to enter is at I. Okay, so I will be a new index, right? So that means this will become 5, which is pointing at I, and we have to place 10 right here. Okay, so that is about the linear search. So this is the solution number 1. Let's just code it out, then we'll get back to solution number 2. So this is approach number 1. It is a brute force solution. What we can do is we can set the initial and as nums dot size. Okay, and we can check if for int I is equal to 0, I less than n, I plus plus, if nums of I is greater than equal to target. It means we found the first element where which is greater than the target, right? It means we were searching at 0. Suppose we had numbers like 0, 2, 4, 6, 8, 8, and the element we wanted to enter was 9, right? We wanted to insert 9. So 0 was less than nums uh, than the target, 2 was less than, 4 was less than, 6 was less than, 8 was less than, but 10 was not less than 9. Okay, 10 is greater than 9. In that case, what we want to do is we simply want to return the index we went ahead. Okay, so we went ahead by I index. So I was pointing at there, then I was pointing at this point. After that, I will be pointing at this point. Okay, so we want to return I, so this is where we want 9 to be placed. Okay, so it will take the position of 9 and 10 will be shifted rightwards. We will return right I, otherwise we'll return 10. Okay, so that means this is the condition where we do not suppose we want to place 11. Okay, where will 11 be placed? It will be placed at the end. Okay, so this is it for the brute force solution. Now let's go and do the proper solution, binary search solution. So we have already done with the first approach, that is doing the linear search and finding the element where we can place. It's finding the position where we can place our element. Okay, so let's do the binary search and do the same thing. So let's place the element as S and E, set the indexes, and let's calculate the mid now. The mid is going to be S plus E by 2. So the mid is going to be 0 plus 6 by 2. It is going to be 3. Okay, so mid. Okay, so once we have mid, we will check a condition if array of mid is greater than equal to target. Okay, let's say the element we want to search for is t is equal to 10. Then what we can do is we can check if the array of mid is greater than target. So right now the mid is pointing at mid is 3 and it is pointing at 7. So 7 is greater than equal to target. Target is 10. No, it is not, right? So if that condition is false, okay, if this entire if this condition if this condition is false, then we will do some code. Okay, so let's execute that code in else block. We'll do some code. Let's understand the condition first. Okay, so to understand the condition, what we can do is we can draw a number line. Okay, let's call it S and let's call it E, and this is where the mid is. And when we say that array of mid is greater than target, what we are saying actually is the target must lie on this is where the target can be, and this is the array of mid. Okay, this is the array of mid. That means whatever the number is, it should lie whatever the t is, it should lie on the left side of that mid. So essentially what we can do is we can say the end pointer and move it to right here. Okay, so in the if block, what we can say is e is equal to mid minus 1. And before doing this, what we can say is we can store the answer. We can create an answer variable and set it as mid. Okay, so this can be our answer. Otherwise what we can do is we can say otherwise let me explain the condition number 2. Okay, the target exists on the right side and it is much greater than the array of mid. Okay, so the target exists on the right side. That means this is where the target is. Okay, and it is much greater than the array of mid. So essentially these were our S and E. That means if it exists on the right side, it does not exist on the left side. Okay, so we can take S and we can move it around here. Okay, that is mid plus 1. Okay, so in this case what we're going to do is S is equal to mid plus 1. Okay, so using number line we can understand it just fine. And so this is essentially the most important code. And once we do all the iteration, we will have the answer inside the answer variable. So let's do a quick dry run. So essentially array of mid is 7. Okay, array of mid is 7 and 7 is greater than equal to 10. 7 is greater than equal to 10. No, 7 is not greater than equal to, so it will go to the else block. So it goes to the S block and sets the mid is equal to S is equal to mid plus 1. S is this and it will go to mid plus 1. That means the left half is eliminated. So I'm just going to draw this and exclude it like this and move S as right here. Okay, once this is done, and the target was 10, right? Okay, so I'll draw target as 10 right here. Okay, so once this is done, we have S and E again. So we'll calculate mid again. Mid is equal to S plus E by 2. S is 4 plus 6 by 2, that is going to be 5. So this is where the mid is pointing at. We'll check the condition again. If array of mid is greater than equal to target, what is of array of mid? It is 11. So 11 is greater than equal to target. What is target? What is target? What is target? Target is 10. Okay, so this condition is true. If that is true, then what we'll do is we will store the answer as mid. Okay, so this is where we can place the element. So essentially this is where we can place the 10. So we can place the element at mid, that is around here. And we can, since we no longer require the right side, we can say the E as mid minus 1. So it should go at mid minus 1. What is mid? Mid is at 5. Minus 1 is going to be 4. So essentially we're going to take S and E and move it to here. So let me do it. Don't require the right side, so we are going to discard the right side. But before that, we are going to place E as here. So S and E as are pointing at 4. Okay, let's calculate mid again. Let's calculate mid again. So mid is going to be 4 plus 4 by 2. It is going to be 4. So mid is also pointing at same. Okay. So what is array of mid? Array of mid is going to be 4. Okay, is it greater than equal to 10? No, it is not true. So the moment S goes right here and E goes right here and they both have overlap, this is when we are going to stop the binary search. Okay, so this is where we are going to stop the binary search, and we're going to say we already had the answer. We already had the answer in the answer block, right? So answer was mid. Okay, so the answer is going to be mid. So what is mid? Mid is at index number 5. So this is where the answer was lying at previously. Remember? So this is where we stored previous answer. This is where we stored answer previous answer. Though the answer contained the variable number 5. Okay. So let's just do dry run on another question. Let's say we want to place target as 0. Okay, we want to place 0, element number 0. So if you think logically, the element 0 should lie somewhere around here. That is at the 0th index. Okay, so to do that, what we can do is we can say the starting and ending indexes. Okay, and then we can calculate mid. What is mid? Mid is going to be 0 plus 6 by 2. Mid is pointing at 3, so this is where the mid is going to point. We can check if the array of mid is greater than target. So what is array of mid? Array of mid is pointing at 7. 7 is greater than equal to target. What is target? 0. Yes, it is true. If this condition is true, the target is 0 and array of mid is pointing at 7. That means there is no way the element lies on the right side. So we're going to discard the right side. Okay, so let's discard the right side. Does not exist, and we'll take the E pointer and point it right here. Okay. Uh, let's start again. Let's calculate mid. So mid is going to be S 0 plus 2 by 2. It is going to be 1. So mid is going to be 1. So what is array of mid? Array of mid is 3. So 3 greater than 0. Okay. Is 3 greater than 0? Yes, 3 is greater than 0. If that is the case, then this block will be executed. We'll store the answer. The previous answer was, let's store the answer as 3. And then we'll set the E is equal to mid minus 1. The E goes right here. Okay, so E is pointing at right here. It means the right side was again discarded. So this much is discarded. Okay, so let's calculate mid again. Let's calculate mid again, and it will become mid is equal to S plus E by 2. S is 0 plus E0 by 2 is going to be 0. So mid is also pointing at right here. Okay, so if S and E are both pointing at that point, That means let's run it. If array of mid is 1, is 1 is 1 greater than 0? Yes, it is true. Then we'll store the answer as mid. So the answer will be 0. So previously whatever the answer was, we'll override with answer as 0. Okay, once this is done, what we can do is, uh, once this is done, we can set e is equal to mid minus 1. E was pointing at 0 and mid was pointing at 0. So so e is going to be minus 1 now, and s is going to be 0. Okay, so e is going to be minus 1 and s is going to be 0. The moment this happens, when they both overlap, this is when we are going to stop the binary search. Okay, so that means the answer, we had already said, we had the answer in the answer variable, and it is actually 0. That is it for the approach number 2, and let's just go and code it out. Okay, log in. Okay, so let's get started. Let's do the binary solution. So what we have is, initially we will set s as 0, and the ending index would be nums.size minus 1. Or we can do is, what we can do is, we can say int n is equal to nums.size, and we can simply do e as n minus 1. Okay, so while s is less than equal to e, okay, we are going to execute the code. Mid is equal to s plus e by 2. Okay, I've already told you we can do the other mid calculation as well, which is safer. We're gonna do if nums of mid is greater than equal to target. Okay, that the target we want to place. So if nums of mid is greater, then the target is definitely smaller, and if the target is smaller, it should lie on the left side. Okay, and if it does lie on the left side, that means the right side is discarded. Okay, so we'll do mid minus 1, and before doing that, we're going to store the answer as mid. Okay, let's create a variable answer, and let's just store the value n in it. N minus 1 we can do. Oh, it's fine, n is fine. Else, what we can do, the target does not exist on is equal to mid minus 1. Target exists on the left side, we said, right? In this scenario, the target exists on the right side, is equal to mid plus 1. Okay, and if that is not, and once we have that, we will do the answer. Okay, so let's run the solution. Okay, so let's print out the solution. What it says, answer is 2. So it exists, so the number 4 should lie on 0, 1 and 2 index right here. So let's say, where will 0 be placed? It will be placed at the 0th index. So yeah, that's it for the binary search. Have a great day. So that is it for the solution today. That is it for the video today, and I'll see you in the next video. Bye.